Hey everyone, here is an answer key for the Trig Lesson 3 homework. Okay, and remember, when we are working with 90-degree triangles, we can use the acronym SOHCAHTOA. It stands for sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. So with number 1, find the required ratio in fraction form. What is cos of m? Here is the angle m. And so across from angle M would be labeled the opposite side. Across from the 90 degrees is the hypotenuse, and so the side adjacent to M is the 12. And we want the cosine of angle M, and cos is the adjacent side divided by the hypotenuse. So I would simply go adjacent side 12 divided by hypotenuse 13. So that is the cosine of angle M. Tan of M, if we're talking about angle M, the triangle is labeled the same way. Opposite side, the hypotenuse is always across from the 90, and the adjacent side is 12 in this case. So tan of M, tan is opposite divided by adjacent. So I would simply go opposite is 5, divided by adjacent 12. Okay, and you can see that these answers are consistent with the answer key at the end. Letter C, sine of M. Sine is opposite divided by hypotenuse. So the opposite side to M is the 5. The hypotenuse is 13. And we are done 1, A, B, and C. Okay, and notice that D, E, and F deal with the angle K, so that's going to change our labels a little bit. Okay, remember the hypotenuse always stays the same, but opposite and adjacent will now switch because we are talking about angle K. So the opposite side to K is 12, and the one that's right beside angle K is the adjacent, that's 5. Okay. So they want us to figure out sine of angle K. Sine is opposite divided by hypotenuse. So in terms of angle K, the opposite side is 12. The hypotenuse is 13. Cos of K, notice that cos is adjacent divided by hypotenuse. So we look at angle K, the adjacent side is 5, divided by the hypotenuse is 13. And letter F, tan of K. Tan, notice, is opposite divided by adjacent. So you would go, the opposite side is 12 divided by the adjacent is 5. And that is how you do number 1. All right, let's get on to number 2 here. For each of the following triangles, find the indicated side or angle. For each question, 1, label the triangle sides OA or H, opposite, adjacent, or hypotenuse. 2, write the trig ratio you'll use to solve. And 3, solve the angle or side to 1 decimal place. Okay, and notice they're all 90-degree triangles, so we can use our little acronym SOHCAHTOA. Tells you which trig ratio you're using. Okay, so for 2A, they've given us an angle. They want us to find side labeled A, and we've got across from the 90, that is the hypotenuse. And since we have this angle, across from that angle is the opposite, so that's the opposite. So the A here must be adjacent. Okay, so notice, guys, we are going to be dealing with the adjacent side and the hypotenuse. What deals with adjacent and hypotenuse? Cos. So you go cos of 34 degrees is equal to, the adjacent is A, the hypotenuse is 15, and then we have a small little equation here to solve for A. A is being divided by 15, so we simply multiply both sides by 15. And we will get that A is equal to 15 times cos 34 degrees. And since our angle is in degrees, make sure you're in degree mode. See how degree is highlighted. I go 15 times cos 34, and my answer is 12.4. We're supposed to go to 1 decimal place. All right, letter B. Here's our angle that we have. Straight across from that is the opposite side. Across from the 90 is the hypotenuse, so 16 must be adjacent. And so notice, guys, we want to find that opposite side labeled B, and we have the adjacent side 16. And so notice the hypotenuse, there's no label on it, so we know that we don't want to find that side. So I'm going to be working with opposite and adjacent. Opposite and adjacent comes from tan, so you just go tan of 23 degrees is equal to, the opposite is B, that's what we want to find, the adjacent is 16. And we solve this little trig equation for B. B is being divided by 16, so I simply multiply both sides by 16. And I'm going to get, B is now by itself, it is 16 times tan 23. 16 tan 23, and we get 6.8 to 1 decimal place. And there's no centimeters or anything like that, so we'll just write it as 6.8. All right, how about letter C? Here's our angle that we have. Right across from it is the opposite, and across from the 90 is the hypotenuse. We're looking for the opposite side. It's labeled C, and we have the hypotenuse. Which one deals with opposite and hypotenuse? That would be sine. So you go sine of 62 degrees is equal to, the opposite side is C divided by 9. And if I want to get C by itself, it's being divided by 9 right now, so you have to multiply both sides by 9. That cancels to 1, so C is by itself now. And we can go that C is equal to 9 times sine 62. And we get 7.9. Okay, the answer key in the back says 8.0, but that's not entirely rounded correctly because there's a 4 beside the 9, so that 9 would remain, so it should be 7.9. Alright, how about letter D? We have this angle. Right across from it is the opposite. Across from the 90 is the hypotenuse, which means D must be the adjacent side. So we are going to be working with opposite and adjacent. So katoa, opposite and adjacent, comes from the tan function. So tan of 27 degrees is equal to, opposite is 14 divided by adjacent is D, and we need to solve this for D. Okay, and so remember when we're in this situation that the D and the tan 27 end up switching spots. That was our little trick. And so D is equal to 14 divided by tan 27, and we end up with 27.5 for that adjacent side. Alright, let's check out letter E. Here's the angle that we have. Right across from it is the opposite. Across from the 90 is the hypotenuse, leaving this side to be adjacent. So we have the adjacent and we're looking for the hypotenuse. So which ratio, sine, cos, or tan, deals with adjacent and hypotenuse? That is going to be cos. So we would go cos of 38 degrees is equal to adjacent divided by hypotenuse. And we need to get E by itself. It ends up switching like that. So E is equal to 16 divided by cos 38. And so E is equal to 16 divided by cos 38. And we get 20.3. Alright, in letter F, we have this angle. Across from it is the opposite side. Across from the 90 is the hypotenuse, so the 18 must be the adjacent. We have the adjacent, we're looking for F, the hypotenuse. Which trig ratio deals with adjacent and hypotenuse? That's cos again. So it would be cos 51 degrees equals adjacent 18 divided by hypotenuse F. And when the unknown letter is on the bottom of the fraction, those guys end up switching spots. And we get F is equal to 18 over cos 51 degrees. Okay, so F is equal to 18 divided by cos 51. Bang, 28.6. Alright, let's check out letter G. This time we're trying to find an angle. They've labeled one of the angles with the symbol beta, which is a Greek letter which is often used for angles. So we're actually trying to find the angle in these next three questions. Okay, and so based on the angle we want to find, you have to label the sides of the triangle. So across from beta is the opposite, which we don't know. Across from the 90 is always the hypotenuse, which means this one must be adjacent. So we've got the adjacent side and the hypotenuse. So if we do that SOHCAHTOA thing again, we have the adjacent and the hypotenuse, so we must be using the cos ratio. So cos of angle beta is equal to adjacent 3.8 divided by hypotenuse 10.2. And remember, to get an angle, when you have the ratio, you have to use the inverse trig functions. So we have to go cos inverse of 3.8 over 10.2. So you go shift cos 3.8 divided by 10.2 and press equals 68.1 degrees. So we're finding an angle in degrees this time, and that is 68.1 degrees. All right, letter H. This time we're trying to find that angle there. I can't remember the name of that Greek letter. I think it's phi. Right across from the angle is the opposite side. Across from the 90 degrees is the hypotenuse, and those are the two that we have. So we're going to be dealing with opposite and hypotenuse. This remaining side is adjacent, but we don't know what it is. So what deals with opposite and hypotenuse? O and H, opposite and hypotenuse, comes from sine. So we're going to go sine of this phi symbol equals opposite 4 divided by hypotenuse 7. So then angle phi is going to equal sine inverse of 4 over 7. Shift sign, 4 divided by 7, bang, 34.8 degrees. Okay, and finally letter I here in number 2. We're looking for this angle. That's the capital letter theta. And across from that angle is this side, which is the opposite side. And across from the 90 is the hypotenuse. So this must be adjacent. So we're going to be working with opposite and adjacent, O and A. And that comes from tan. So you go tan theta is equal to opposite, 8.1, divided by adjacent, 6.4. And so theta is going to be tan inverse of 8.1 divided by 6.4. Shift tan, 8.1 divided by 6.4. And we get 51.7 degrees because we're finding an angle. Okay, and here is number 3. For each of the following word problems, 1, sketch a good diagram which has all information labeled on it, including missing side. 2, write the trigonometric ratio you will use. And 3, solve and write a sentence which tells you what you solved for. Okay. So in A, how tall is a tree if its shadow is 36 meters long? And the angle that the shadow makes with the ground is 43 degrees. Okay, so we've got a tree here. Let me attempt to draw a tree. Okay, there's my tree. How tall is the tree? So we want to find the height of the tree if its shadow is 36 meters long. So imagine the sun is like this, shining. Hits the tree. Shadow is this dark space along the ground down here, so the shadow is 36 meters long. Excuse me. I don't have coronavirus, my children, I promise. Just sort of little allergies and stuff. Okay, so the shadow's 36 meters long. The angle that the shadow makes with the ground is 43 degrees. They're talking about that angle right there. It should really maybe say the angle that the sun makes with the ground. That's kind of a confusing question. Okay, how tall is the tree? We're looking for h. Okay, and so the implied 90-degree angle then is right here. So there's where your 90 degrees is. And now we can label the triangle. We have this angle, so straight across, this is the opposite side. Across from the 90 is the hypotenuse, and this is adjacent. Okay, so we want to find the opposite side h, and we have the adjacent. So which ratio deals with opposite and adjacent? Remember SOHCAHTOA. Opposite and adjacent comes from tan. So we would go tan of 43 degrees is equal to the opposite side h, the height of the tree, divided by 36 meters, the length of the shadow. And then we can solve this for h. So multiply both sides by 36. And so h is equal to 36 times tan 43. .6 meters. Okay, and we could just say this is the height of the tree. Boom. Okay, so there's 3A. Letter B, on a sunny day, the sun's rays strike the ground at an angle of 53 degrees. A tree 18 meters in height casts a shadow. How long is that shadow? Okay, so a tree again. We'll make it a tree like this time. Sun is up here, beating down. And its rays go like this, boom, hit the tree, and the tree casts a shadow like this. Okay, and the tree is 18 meters in height. There's our 90 degrees. The sun's rays strike the ground at an angle of 53 degrees. And how long is the shadow? So we want to know, hey, what's this x length right here of the shadow? So there's our triangle. Let's label the sides based on this angle. Across from that angle is the opposite side. Across from the 90 is the hypotenuse, so this is the adjacent. So they want us to find the adjacent length, the length of the shadow, and we have the opposite. Okay, so which trig ratio deals with opposite and adjacent? Which one deals with opposite and adjacent? That would be tan. So we would go tan of 53 degrees is equal to the opposite side is 18. The adjacent is the length we want to find, x. Okay, so we set up our little equation like that, and those two will end up switching spots. So x will equal 18 divided by tan of 53 degrees. 18 divided by tan, 53, gives us 13.6. That's going to be in meters because the height of the tree was in meters. 13.6, and this is the length of the tree's shadow. So the length of shadow. Okay, and that is how you do 3B. Alright, let's check out C. A ladder is resting against a wall and makes an angle of 61 degrees with the ground. If the base of the ladder is 2.3 meters from the wall, how high does the ladder reach up the wall? Okay, so we've got a ladder like this. We've got the wall. And we have the ground. So that's the ladder. This is the wall. And this is the ground. There's our implied 90-degree angle. Okay, and a ladder is resting against a wall and makes an angle of 61 degrees with the ground. So 61 degrees is here. If the base of the ladder is 2.3 meters from the wall, so here's the base of the ladder, saying that it's 2.3 meters from the wall. Okay, so that's the base of the ladder. It's 2.3 meters from the wall. How high does the ladder reach up the wall? So the ladder hits the wall up at that point there, and we want to know what is this height. Okay, so there's our triangle. We have the 61 degrees. Across from the 61 degrees is the opposite side. Across from the 90 is the hypotenuse, leaving this side to be the adjacent. Okay, and so notice, guys, that we have the adjacent side and we are looking for the opposite side. So O and A, and that comes from TOA, so it will be tan again. So we go tan of 61 degrees is equal to opposite side H divided by 2.3, the adjacent side. And this is one of the easier ones to solve, right? H is being divided by 2.3, so we multiply by 2.3 to get back to H, and whatever you do to one side, you have to do to the other. Okay, H is by itself now. It's equal to 2.3 times tan 61. 4.1 to 1 decimal place. And that's going to be in meters because we were given that the base of the ladder is 2.3 meters from the wall. Okay, and so the ladder reaches up the wall 4.1 meters. Okay, and I notice in the answer key they've got 4.2. Again, that's just a small rounding mistake there because there's a 4 beside the 1, so that should stay as 4.1. Okay, let's get on to letter D. A wire supporting the top of a hydro tower meets the ground at an angle of 59 degrees. The wire is secured 22 meters from the base of the tower. How high is the tower? Okay, so we've got this wire that's sort of holding up this tower. And a wire supporting the top of a hydro tower meets the ground at an angle of 59 degrees. So the wire is hitting the ground. At 59 degrees. The wire is secured 22 meters from the base of the tower. The base of the tower is the bottom here. And so the wire is secured over here, which is 22 meters. Here's our 90 degrees. How high is the tower? So we want to figure out H, this height. Okay, and so given that we have that angle 59 degrees, straight across from it is the opposite side. Across from the 90 is the hypotenuse, so this 22 is the adjacent. Okay, and again, we want to figure out how high the tower is, so we want to figure out H, and we have the adjacent. So opposite and adjacent again, which comes from tan. If I were to write out SOHCAHTOA, which ratio deals with opposite and adjacent, that is tan. And see how we're looking for the opposite side and we have the adjacent. Hypotenuse we don't know and we don't need to know. Alright, so I would go tan of 59 degrees is equal to opposite is H, adjacent is 22, and we are ready to solve. Multiply both sides by 22. And we get H is excuse me, equal to 22 times tan 59. 22 times tan 59, 36.6. And that is going to be meters. It's the height of the tower. Alright, letter E. From a point 132 meters above the ground in a control tower, the angle of depression to a truck on the ground is 38 degrees. How far is the truck away from the observer in the tower? Okay, so we've got this tower. And from a point 132 meters above the ground in a control tower, so this is 132 meters up. The angle of depression to a truck on the ground is 38 degrees. So remember, the angle of depression, guys, is the angle that goes down from that horizontal dotted line. So the angle of depression down to the truck is actually this angle right here. That is 38 degrees. And then this completes our triangle, so there's our 90 degrees. And it wants to know, how far is the truck away from the observer in the tower? Okay, so it actually wants to know the straight line distance from the truck up to the person in the tower. So it wants to know this length x right here. All right. So we have to do one more important thing before we can solve this. Is you'll notice, guys, that we have the angle of depression right here, but we don't have either of these angles inside the triangle. And so what you have to do is you have to get an angle in the triangle first before you can do SOHCAHTOA up. And so remember, this dotted line is the horizontal. So from the dotted line all the way to the tower, that's going to be 90. So to get the angle inside the triangle, we have to go 90 minus 38. So 90 minus 38 is 52. So this angle right in here is 52 degrees. And now we have an angle inside the triangle. And then we can label the sides based on that angle. So there's the 52 degrees. Right across from it is the opposite side. Across from the 90 is the hypotenuse. That's what we want to find. Leaving this side to be the adjacent, the 132. Okay, so notice I've circled adjacent and hypotenuse. SOHCAHTOA, which one deals with adjacent and hypotenuse? Cos. So it would just be cos of 52 degrees equals the adjacent is 132, the hypotenuse is x. That's what we want to find. And remember, this is the type where the cos 52 and the x just switch spots. But if you want to see why that is again, what you'd have to do is multiply both sides by x to get rid of the dividing by x. And then notice how we get x cos 52 degrees equals 132. And now we have to divide both sides by cos 52. And see how the cos 52 ends up underneath the 132. Okay, so the x and the cos 52 just switch spots. Okay, so x is equal to 132 divided by cos 52, and we get 214.4. That is going to be in meters. And this is this is how far the truck is away from the observer. And that is letter E. Okay, let's try letter F. An observation tower is 98 meters tall. The angle of depression from the top of the tower to a historical marker is 23 degrees. How far from the base of the tower is the marker? Okay, so we've got a tower again. And it says that this is 98 meters tall. The angle of depression from the top of the tower to an historical marker is 23 degrees. Okay, so remember the angle of depression is the angle down from the horizontal. So there's the horizontal dotted line. And the angle down to this, some historical monument here. This is 23 degrees. How far from the base of the tower is the marker? The base of the tower is the bottom of the tower. How far away is that historical marker from the base of the tower? Okay, so we want to figure out that x length. Here's our 90 degrees, and this is 98 here. And again, if we've got the angle of depression being 23 degrees, we have to get the angle inside the triangle. And you can get that by going 90 minus 23 degrees. 67 degrees. So this angle right in here is 67 degrees. Okay, so based on the 67 degree angle, the x is the opposite. Across from the 90 is the hypotenuse, which means the 98 is the adjacent. We have the adjacent, we're looking for the opposite. Opposite and adjacent. SOHCAHTOA. Opposite and adjacent comes from tan, so we go tan 67 degrees equals the opposite is x and the adjacent is 98. Multiply both sides by 98. X is equal to 98 times tan 67. So we go 98 tan 67. Bang, 230.9. meters. Okay, and so we can say the marker is this far away from the base of the tower. Okay, let's get on to letter G. A monument 18 meters high casts a shadow 22 meters long. Calculate the inclination of the sun to the horizontal at this time of day. Okay, so (18-meter monument casts a shadow 22 meters long. So imagine the sun up here shining down, and the sun rays come down like this. Hit the ground over there, and they cast a shadow 22 meters long. There's the 90 degrees. Calculate the inclination of the sun to the horizontal at this time of day. So the horizontal would be like the ground, or any line parallel to the ground, and so the angle of inclination or angle of elevation up to the sun would be that one. So they want us to calculate that angle that the sun's rays are making with the ground. Okay, and so let's call it theta. Okay, so we want to find angle theta. Let's label the triangle based on that angle. So across from that, that is the opposite. Across from the 90 degrees is the hypotenuse, so this one is adjacent. So we have opposite and adjacent. And that deals with the tan ratio. Opposite, adjacent comes from tan. So we would go tan theta is equal to opposite 18 divided by adjacent 22. And remember, to figure out an angle, we have to do tan inverse of the ratio. And so theta is equal to shift tan 18 over 22. Bang. 39.3 degrees. Okay, and that is the angle of inclination of the sun. Letter H. A pilot in a plane 3 kilometers above the ground estimates the angle of depression to a runway as being 51 degrees. How far horizontally is the pilot from the runway? Okay, so I am going to attempt to draw a plane. That's pretty good for me, I think. I'm not a skilled artist. Okay, so a pilot in a plane 3 kilometers above the ground. We will say that is 3 kilometers. Estimates the angle of depression to a runway as being 51 degrees. So the angle of depression down to the runway is 51 degrees. How far horizontally is the pilot from the runway? So we want to figure out this distance here, x. And the runway will be this nice red thing here. Okay, so we need to figure out x. There's our 90 degrees, and since we have the angle of depression, we have to get the angle inside the triangle. And so you go 90 minus 51 to get the angle inside the triangle. That is 39 degrees. And now that we have that angle, now we can label the sides of the triangle. Across from that is the opposite, which is what we want to find. Across from the 90 is the hypotenuse. And this is the adjacent. Okay, so I've circled opposite and adjacent. OA comes from TOA, so we use the tan ratio. Tan of 39 degrees is equal to, the opposite side is x, the adjacent is 3. And we solve this for x. X is equal to 3 times tan, 39. 3 times tan, 39. Bang. 2.4. That would stay as 2.4, and that is going to be kilometers because the height of the plane is 3 kilometers. Okay, and so this is the plane's horizontal distance from runway. Horizontal distance from runway. All right, 2 more. Just want to double check that. Yeah, 2.4. Okay, letter I. The firing angle of a missile is 28 degrees. How high is it after it has traveled 450 meters? Okay. So there's a missile. It's fired out like this. I'm not a very good artist. There's our 90-degree triangle. The firing angle of a missile is 28 degrees. Okay, so it's fired at 28 degrees above the horizontal. How high is it after it has traveled 450 meters? Okay, so the missile travels along that diagonal line, 450 meters. Okay, and we want to know, okay, after it has gone this 450 meters, how high is it? So h. Excellent. So with the angle 28 degrees, across from that is the opposite side. Across from the 90 is the hypotenuse. This side is the adjacent. That's not going to come into play. So we're looking for the opposite, and we have the hypotenuse. Which trig ratio deals with opposite and hypotenuse? That comes from sine. So you would go sine of 28 degrees is equal to, the opposite is h, and the hypotenuse is 450. So to get h by itself, you do 450 times sine 28, bang, 211.3 meters. That's how high the missile is. Okay, so this is height of missile. Oh, thank you. Height of missile. After traveling 450 meters. And finally, letter J. The top of a lighthouse is 110 meters above the level of the water. The angle of depression from the top of the lighthouse to a fishing boat is 18 degrees. How far from the base of the lighthouse is the fishing boat? Okay. Here's the lighthouse. There's the water. The top of a lighthouse is 110 meters above the level of the water, so there's 110 meters. The angle of depression from the top of the lighthouse to a fishing boat is 18 degrees. Okay, so remember the angle of depression is the angle that goes down from the horizontal to the object you're interested in. Okay, and so the angle of depression is right here, 18 degrees. Okay, and we want to know how far from the base of the lighthouse is the fishing boat. So remember that the base of the lighthouse is there, and we want to know what is this length x. Okay, so we have to get an angle inside the triangle, and so remember from the 90-degree from the dotted line to the lighthouse, that's 90 degrees. So you go 90 minus the 18 to get that angle that's inside the triangle, 72 degrees. Okay, so this is 72 degrees, and now we can use that angle. And we can go, hey, 72 degrees. Straight across from it is the opposite side. This is where the 90 degrees would be. This is the hypotenuse then. And so the 110 is the adjacent. Okay, so we have the adjacent, and we are looking for x, the opposite side. And so which trig ratio deals with opposite and adjacent? So we'll do SOHCAHTOA yet again, because we have a 90-degree triangle. Opposite, adjacent comes from tan. Beautiful. So tan of 72 degrees is equal to opposite side x divided by adjacent 110. And we solve this for x. Multiply both sides by 110. And we get x is equal to x is equal to 110 times 10, 72, 338.5, and that's going to be meters. And we can say the fishing boat I'm going to try this again. pick up the eraser. There we go. The fishing boat is this far away from the base of the lighthouse. Okay, and I notice in the answer key they have 338.6. Okay, but again, that should stay at 0.5. Okay, there you go, everybody. That is an answer key for Trig Lesson 3 homework. And as usual, I'll send you a new learning task early next week.